So for question 2, we had to work out these powers of I. So remember what I said about the powers of I is that they move around in a loop, if you will, that there are only 4 possible answers for any natural number that is the power of I. So they start with I, then -1, minus I, and then 1. So then depending on what your exponent is, your answer is one of the following. And the way to know what the answer is you take your exponent, you divide it by 4, whatever the remainder is, then that is going to tell you what the value of I to that power is. So the first one is very simple. You have we have I to the power of 284. So like I said, you divide 284 by 4. Okay, so I have my calculator over here. So I say 284 divided by 4. The answer is 71. So you can see there's no remainder. So this is equal to I to the power of 0, because the remainder is 0, and I to the power of 0 is equal to 1. Anything except 0 to the power of 0 is equal to 1. Then the next one, I to the power of 2 times 10. Here you can work it out in one of 2 ways. So first you can rewrite this as I to the power of 2 to the power of 10 using your laws of indices. When your exponents are multiplying, it means that you are raising I to the power of 2 and then to the power of 10. Then this you can work out as -1 to the power of 10, because 2 here, when I divide it by 4, the remainder is 2, so it's just I to the power of 2. And then -1 to the power of 10, this is very simple. This is just equal to 1. So the other way you could do it is I to the power of 2 times 10. This is I to the power of 20. Then I do the same thing I did on my calculator. 20 divided by 4. I don't need a calculator for that. I should be able to do it without a calculator. 20 divided by 4 is 5. The remainder is 0. So this is the same as I to the power of 0. And on our loop, remember we start here. This is I to the power of 1. Then we go to -1, and then we go to minus I, and then here we go to 1, and then we're back to I. So here the remainder is 1, 2, 3, and over there the remainder is 0. Remember, when you're dividing anything by 4, your remainder is either 0, 1, 2, 3. It cannot be 4, because that means you can still give every person 1 more if there's 4 left. Okay, so here that's our loop. So here I have I to the power of 0, so the answer is equal to 1. Then C, I to the power of 26 times I to the power of 15 divided by I to the power of 72. So here you can use your laws of indices. You can see here the bases are all the same. I'm multiplying here, I'm dividing, so I can add those 2 together and then subtract that one. That is also fine. Or you can work out the value of this, the value of that, and the value of this one. Now here, 26, I can divide it by 4. When I do divide it by 4, the remainder is 2. So I have I to the power of 2. And then 15, when I divide it by 4, the remainder is 3. So this is I to the power of 3. And then 72, when I divide it by 4, there is no remainder. So this is I to the power of 0. Okay, so here you just need to know how to get that remainder, and then you go back to your loop and see, okay, I to the power of 2, this is -1, so I have -1. I to the power of 3, this is minus I, so here, let me just write them like that, just to distinguish them. So I to the power of 3, this is minus I, and then divide by I to the power of 0, this is 1. So this is a simple expression to solve. Negative negative gives me a positive, so I have positive I divided by 1. Anything divided by 1 is just that thing by itself, and that is why the answer is equal to I. Next one, we have I to the power of 19 times I to the power of 27 minus I to the power of 21. Okay, so with this one over here, we do the same thing. 19 divided by 4, the remainder is 3. So this is I to the power of 3. And then 27 divided by 4, the remainder is 3. So I have I to the power of 3. And then here I'm subtracting. This one is different from the division over here. With this division, I could subtract the exponents, but here I'm subtracting. There is no law of indices that say if I'm subtracting two terms with the same basis, then I can subtract the exponents. I cannot do that. So here, this is I to the power of 1, because when I divide 21 by 4, the remainder is 1. Then these ones, I go to my loop. I to the power of 3 is negative I. Let me just write that. Okay, times negative I minus I to the power of 1. This is just I. So negative and negative will give me a positive. So I'll have positive I squared. I squared, let me just write that. This is positive I squared minus I. I squared, according to my table, is minus 1. That is okay. So I squared minus I cannot combine them because the bases, this is I to the power of 2, and this is I. They are not like terms, so I just need to work this one out according to my loop. So I to the power of 2 is over here. The remainder is 2, so it's negative 1. That's why I have negative 1 over here. And then I have minus I. These two cannot be combined because they are not like terms. This is a real number. This is purely imaginary. I cannot combine them, and that is why that is my final answer.